Question 1. Among the various challenges in ductwork installation, Mr. Davis notices uneven airflow and high static pressure in a new commercial HVAC system. He suspects the duct sizes might be incorrect for the designed airflow. What is the best initial approach Mr. Davis should take to address the issue? A. Increase the fan speed to compensate for the high static pressure. B. Verify duct sizing calculations and compare them with actual measurements. C. Add additional duct insulation to reduce pressure loss. D. Seal all duct joints with tape to improve airflow. Answer. Correct answer. B. Explanation. The first step is to verify duct sizing, since improper duct dimensions directly cause increased static pressure and airflow imbalance. Increasing fan speed without addressing sizing can cause noise, energy inefficiency, and equipment strain. Adding insulation does not influence static pressure or sizing, only heat loss gain. Taping joints improves leakage but won't fix undersized ducts, causing pressure problems. Checking calculations and physical measurements aligns the system with design requirements, adhering to SMT and industry airflow principles, ensuring proper velocity and pressure for system performance. Question 2. Given the circumstances, Mr. Patel must fabricate a duct elbow to fit a tight space where the radius must be as small as possible without causing excessive pressure loss. Which factor is most critical for Mr. Patel to consider during fabrication? A. Use the thinnest sheet metal possible to reduce weight. B. Ensure the elbow radius is at least 1.5 times the duct width to minimize turbulence. C. Increase the elbow angle to 90 degrees to save space. D. Use a welded seam instead of a Pittsburgh lock for added strength. Answer. Correct answer. D. Explanation. Choosing a welded seam provides a stronger SI joint, essential in tight radius elbows where pressure loss and leaks can be problematic, while thinner metal reduces weight. It compromises structural integrity. An elbow radius too small causes turbulence and pressure drop. 1.5 times the duct width is industry guidance to minimize these effects, but sometimes space limits this. Increasing the elbow 90 degrees increases pressure loss and noise. Welding ensures a leak-proof, durable fitting critical in such constrained spaces. Question 3. When considering safety practices on site, Mr. Gomez encounters a situation where a large duct section must be cut using power shears near live electrical panels. What is the safest and most compliant procedure he should follow before starting the cut? A. Use insulating gloves and proceed with caution while cutting. B. Perform lockout again on the electrical panel and ensure all power is disconnected. C. Rely on a coworker to watch for electrical hazards while cutting. D. Keep water nearby to quickly extinguish any sparks. Answer. Correct answer. D. Explanation. Actually, lockout again is the mandatory safety procedure to ensure power sources are completely energized before working near live panels. Using insulating gloves alone does not guarantee safety against unexpected energization or arc flash. Relying on a coworker for electrical hazard awareness is unsafe and non-compliant. Water near electrical equipment is dangerous and can cause electrocution or damage. Lockout again follows OSHA regulations and is essential to protect workers from electrical shock or arc flash incidents. Question 4. As demonstrated by the project drawings, Lee needs to interpret a duct layout where transitions between rectangular and round ducts are specified. What is the most important factor Lee should focus on to maintain system efficiency? A. Matching the cross-sectional areas of both duct shapes to preserve airflow velocity. B. Using the thinnest metal gauge for easier forming of transitions. C. Selecting a sharp 90-degree transition to minimize fabrication time. D. Installing additional supports at every joint to prevent sagging. Answer. Correct answer. C. Explanation. The key for efficient airflow is to maintain consistent cross-sectional area during transitions to avoid velocity changes and pressure losses. Using thin metal gauge may ease forming but can compromise durability. Sharp 90-degree transitions cause turbulence and pressure drops, negatively impacting efficiency. Gradual, smooth transitions are preferred. While supports are important, they do not directly affect efficiency. Therefore, the focus should be on smooth, properly sized transitions per SMT guidelines to optimize system performance. Question 5. In the context of duct sealing, ISTA must decide which method to apply on a large industrial HVAC system exposed to outdoor weather. Which sealing approach should he use to ensure long-term durability and compliance with standards? A. Use conventional duct tape for a quick fix on seams. B. Apply mastic sealant combined with fiberglass mesh reinforcement. C. Use aerosol-based sealant injected only inside the ducts. D. Rely solely on mechanical fasteners without sealant. Answer. Correct answer. A. Explanation. Conventional duct tape is not durable or co-compliant for permanent duct sealing, especially in outdoor or industrial environments. It degrades quickly with temperature and moisture exposure. Mastic sealant with fiberglass mesh creates the long-lasting, flexible, and airtight seal meeting SMACNA standards. Aerosol sealants are supplemental and work best in inaccessible areas, but not alone for primary sealing. Mechanical fasteners do not seal joints and allow leakage. Proper mastic sealing prevents energy loss, infiltration, and system inefficiency. Question 6. Based on the information from an HVAC site, ISTA Martinez must select proper personal protective equipment (PPE) before performing welding on duct sections in an enclosed mechanical room. Which PPE combination best protects against common hazards in this situation? A. Safety glasses, leather gloves, and a cotton shirt. B. Welding helmet with proper filter lens, leather gloves, and flame-resistant clothing. C. Face shield, rubber gloves, and a synthetic apron. D. Dust mask, safety boots, and earplugs. Answer. Correct answer. D. Explanation. Welding requires specialized PPE including a welding helmet with appropriate filter lens to protect eyes from UV irradiation, leather gloves for heat protection, and flame-resistant clothing to prevent burns. Safety glasses and cotton shirts provide an adequate protection against welding hazards. Face shields and rubber gloves are inappropriate for welding as rubber gloves do not provide heat resistance, and synthetic aprons, well, dust masks and earplugs protect from particulates and noise but don't protect from welding arc hazards. Therefore, the correct combination is flame-resistant clothing, welding helmet, and leather gloves. Question 7. While examining a duct system installation is new and notices improper hanging supports that allow sagging in long duct runs, what are the likely consequences if these supports are not corrected? A. Increased noise and vibration but no effect on airflow. B. Structural damage leading to leaks and reduced system efficiency. C. Faster air velocity through the ductwork due to decreased cross-section. D. Improved air sealing because of tighter joints from sagging. Answer. Correct answer. A. Explanation. Improper duct supports causing sagging primarily increase noise and vibration because duct sections move and vibrate more easily. This can lead to mechanical fatigue and premature failure. However, sagging alone does not necessarily reduce airflow significantly unless it causes deformation or leaks. Structural damage causing leaks and reduced efficiency results from prolonged sagging if uncorrected. Sagging usually reduces velocity due to increased cross-sectional area distortion, not faster velocity. Tighter joints are unlikely with sagging. Often, sagging loosens connections causing leaks. Question 8. Considering the evidence from recent HVAC projects as to how it must troubleshoot an older duct system with persistent leakage despite previous sealing efforts, which diagnostic tool or method would provide the most accurate identification of leakage locations? A. Visual inspection combined with soapy water to detect bubbles. B. Listening for whistling sounds near joints. C. Performing a duct pressurization test using a manometer. D. Relying on customer complaints to pinpoint problem areas. Answer. Correct answer. B. Explanation. While visual inspection and soapy water can detect large leaks, small or hidden leaks often require more sensitive methods. Listening for whistling sounds is an effective, simple technique to locate leaks. Duct pressurization with a manometer measures overall leakage but does not pinpoint specific locations. Customer complaints are subjective and insufficient for accurate diagnosis. Using auditory clues combined, inspection provides targeted leak location, allowing efficient repair in compliance with standards on duct sealing and system integrity. Question 9. Taking into account sheet metal properties, Johnson must select the appropriate metal type for ductwork exposed to corrosive outdoor environments. Which material should she choose to ensure durability and corrosion resistance? A. Galvanized steel. B. Aluminum. C. Stainless steel. D. Cold-rolled steel. Answer. Correct answer. A. Explanation. Galvanized steel is coated with zinc, offering good corrosion resistance in many outdoor applications and is commonly used for ductwork due to its cost-effectiveness and protective properties. Aluminum is lightweight and corrosion resistant but can be more costly and less durable structurally in harsh conditions. Stainless steel offers the highest corrosion resistance but is more expensive and typically reserved for very environments. Cold-rolled steel lacks corrosion protection and is unsuitable for outdoor or corrosive exposure. Proper material selection ensures longevity and compliance with environmental and industry standards. Question 10. Considering the evidence from a large commercial installation, Turner must determine why the duct system's measured static pressure is higher than design specifications. After ruling out duct leaks, what is the most likely cause Turner should investigate first? A. Incorrect duct sizing causing high velocity and friction losses. B. Insufficient insulation causing thermal expansion and contraction. C. Excessive vibration from improperly secured ducts. D. Use of wrong gauge sheet metal leading to duct deformation. Answer. Correct answer. A. Explanation. High static pressure is commonly caused by undersized ducts that force air to move faster, increasing friction losses. This causes high pressure drops and strain on fans. Insulation mainly impacts thermal performance, not static pressure directly. Vibration can cause mechanical wear but does not create static pressure spikes. Wrong gauge metal may deform ducts, but unless severely bent, it's less likely to cause major static pressure rise. Correct sizing per SMACNA ensures velocity and friction remain within limits, optimizing system efficiency and lifespan. Question 11. From a practical standpoint, Ramirez is fabricating a transition fitting to join a 30-inch by 12-inch rectangular duct to a 16-inch diameter round duct. Which method should she prioritize to minimize airflow turbulence and pressure drop? A. Use the long, gradual transition with smooth internal surfaces. B. Cut the rectangular duct short and make a sharp elbow into the round duct. C. Install a flexible duct section between the two ducts. D. Over-insulate the transition fitting to reduce heat loss. Answer. Correct answer. D. Explanation. While insulation reduces heat loss, it has minimal impact on airflow or pressure drop, so over-insulating does not address turbulence or flow efficiency. The priority should be to create a long, gradual transition with smooth surfaces to reduce turbulence and pressure drop. Sharp elbows and flexible ducts increase turbulence and static pressure losses. Proper fabrication techniques that maintain smooth airflow and gradual changes comply with best practices, ensuring efficient airflow and system performance. Question 12. Under the assumption that a technician like Kim must perform maintenance on a duct system with suspected microbial growth inside, what is the most effective procedure to ensure safe and thorough cleaning? A. Use compressed air to blow out all debris without protective equipment. B. Seal off the system, use HEPA filter vacuum, and apply antimicrobial agents. C. Apply water-based cleaning solutions and leave ducts open to dry naturally. D. Remove insulation around ducts without replacing it afterward. Answer. Correct answer. B. Explanation. Proper microbial remediation involves sealing the system to prevent contamination spread, using HEPA filter vacuum equipment to capture particles, and applying antimicrobial agents to kill microorganisms. Compressed air alone can disperse contaminants into occupied spaces and is unsafe with it. PPE. Water-based solutions without system sealing can worsen mold spread, and removing insulation with replacement reduces thermal efficiency and may increase moisture buildup. Following HEPA and industry guidelines ensures health and system safety. Question 13. By comparing several duct installation scenarios, Evans realizes that duct hangers placed too far apart cause sagging in the ducts. What effect does this sagging most directly have on system performance? A. It increases static pressure losses and creates airflow restrictions. B. It improves duct sealing by compressing seams. C. It reduces noise caused by vibration. D. It reduces duct capacity by decreasing cross-sectional area. Answer. Correct answer. A. Explanation. Sagging ducts deform causing restrictions that increase static pressure losses and reduce airflow efficiency. This forces fans to work harder and may cause uneven airflow distribution. Sagging typically loosens seams rather than compressing them, increasing leakage. It generally worsens vibration noise, not reduces it. Cross-sectional area may not uniformly decrease, but distortion causes turbulence and inefficiencies. Port spacing per SMACNA standards prevents sag and maintains design performance. Question 14. Within the framework of safety, Clark is about to operate a power shear on sheet metal. Which safety precaution is absolutely essential before starting work here? Confirm the blade guard is properly installed and functional. B. Wear cotton gloves to prevent cuts while feeding metal. C. Remove all PPE for better dexterity and visibility. D. Disable the emergency stop to avoid accidental shutdowns. Answer. Correct answer, C. Explanation. Removing PPE for dexterity or visibility is unsafe and against OSHA standards. Operators must wear appropriate PPE, including gloves, eye protection, and hearing protection. The blade guard must be installed and functional to prevent contact with sharp blades. Disabling emergency stops removes critical safety controls. Ensuring guards and PPE are properly used minimizes risk of injury. Safety protocols are foundational in HVAC sheet metal work and must never be compromised. Question 15. In light of recent developments in duct sealing technology, Jackson is choosing between mechanical fasteners and mastic sealants for a new rooftop duct system. What advantage does mastic sealant have over mechanical fasteners alone? A. Mastic provides a flexible air-side seal resistant to vibration and weather. B. Mechanical fasteners offer better airflow than mastic sealant. C. Mastic sealant is easier to remove and reapply during maintenance. D. Mechanical fasteners prevent corrosion better than mastic. Answer. Correct answer, A. Explanation. Mastic sealants create an airtight, flexible bond that resists vibration and withstands weather exposure, essential for rooftop ducts. Mechanical fasteners only hold pieces together but do not seal joints against air leakage. Mastic is generally more permanent and harder to remove than fasteners. Fasteners do not prevent corrosion. The coatings or material selection do. Mastic sealing capability improves energy and indoor air quality by reducing leakage. Question 16. In what ways can sanders improve accuracy during duct layout when using manual measuring tools on complex job sites? A. Measure all dimensions twice and cross-check against blueprints. B. Estimate measurements based on experience to save time. C. Use only a tape measure without additional tools for simplicity. D. Ignore small deviations as they do not affect duct performance. Answer. Correct answer, A. Explanation. Measuring twice and cross-checking ensures accuracy and helps catch errors before fabrication, reducing costly mistakes. Estimation risks inaccuracies. Network ductwork requires precision to maintain airflow and fit. Relying on only one tool limits verification. Squares, scribers, and levels supplement tape measures for layout precision. Ignoring deviations can cause leaks, airflow imbalance, or installation issues. Best practice is systematic measurement and verification, critical for complex duct systems. Question 17. To what extent does metal gauge selection influence the structural integrity and handling of ductwork in large commercial HVAC systems? Thinner gauges reduce weight but can compromise rigidity and increase noise. B. Thicker gauges always reduce noise and cost. C. Gauge selection has no impact on duct longevity. D. Using the thinnest metal available maximizes airflow. Answer. Correct answer, D. Explanation. Choosing thinner metal gauges reduces weight, easing handling and installation, but may compromise duct rigidity, causing vibration noise or deformation under pressure. Thicker gauges improve strength and noise control, but increase weight and cost. Gauge selection directly impacts duct longevity, noise, and performance. Using the thinnest metal indiscriminately does not maximize airflow. It can lead to deformation of flow and causing leaks. Proper gauge selection balances durability, cost, and system requirements. Question 18. The primary reason for specifying insulation on ductwork in a humid climate, as per Istale's project, is to A. Prevent condensation and moisture build-up on duct surfaces. B. Increase the structural strength of the duct. C. Reduce duct installation time. D. Facilitate easier duct fabrication. Answer. Correct answer. B. Explanation. Insulation's main purpose in humid climates is to prevent condensation that leads to moisture buildup, corrosion, and mold growth, protecting both the duct and indoor air quality. It does not significantly enhance structural strength. That depends on metal gauge and construction. Insulation increases installation time and complexity, and it is unrelated to fabrication ease. Proper insulation aligns with ASHRAE and SMACNA guidelines for thermal control and condensation prevention. Question 19. When analyzing the implications of poor duct sealing, is Foster notes increased energy consumption in a building's HVAC system, which is the most direct cause of this increased energy use. A. Increased fan motor workload compensating for air leakage. B. Higher duct surface temperature. C. Reduced system noise levels. D. Decreased duct vibration. Answer. Correct answer. B. Explanation. Poor duct sealing causes air leakage, forcing fans to work harder, thus increasing energy consumption. Increased fan workload is the immediate cause. However, higher duct surface temperatures from heat gain or loss through leaks indirectly cause inefficiency, but as secondary. Reduced noise and decreased vibration are unrelated, or effects of good sealing, not causes of increased energy use. Proper sealing minimizes leak, optimizing fan performance and lowering energy costs. Question 20. In a modern context of duct system, theorist Patel is tasked with reducing noise generated by turbulent airflow in a commercial HVAC duct. Which modification would most effectively reduce this noise without compromising airflow? A. Increase duct size to lower air velocity and reduce turbulence. Add rigid bracing inside the duct to absorb sound vibrations. C. Install sharp 90-degree elbows instead of gradual bends. D. Use thinner gauge metal to increase duct wall flexibility. Answer. Correct answer. C. Explanation. Sharp 90-degree elbows increase turbulence and noise, thus they are counterproductive. Increasing duct size lowers velocity, which reduces turbulence and noise, making it the preferred choice. Rigid bracing might add structural strength, but doesn't effectively absorb noise. Thinner gauge metal increases vibration and noise, reducing system effectiveness. Hence, sizing ducts properly to maintain smooth airflow paths is for noise control as per SMACNA guidelines. Question 21. From a practical standpoint, is new and must determine the appropriate fastening method for attaching insulated flexible ducts to a metal plenum. Which method ensures a secure airtight connection? A. Using zip ties alone to secure the duct. B. Applying duct mastic over a mechanical clamp at the connection point. C. Simply inserting the flexible duct into the plenum without fasteners. D. Wrapping duct tape around the connection. Answer. Correct answer. D. Explanation. Duct tape alone is not recommended as a long-term sealing method. It deteriorates over time. Zip ties provide mechanical fastening but don't create an airtight seal. Proper sealing involves mechanical clamps combined with mastic sealant for durability and airtightness. Inserting the duct without fastening risks disconnection and leaks. Industry standards recommend using clamps with mastic to ensure secure and sealed connections, improving energy efficiency and system integrity. Question 22. While examining the consequences of incorrect duct slope installation in a rooftop HVAC system is to observe standing water in duct sections. What is the most likely impact of this condition? A. Increased airflow efficiency due to cooling effects of water. B. Accelerated corrosion and microbial growth inside the ducts. C. Reduced sound transmission through the ductwork. D. Improved sealing of duct joints due to moisture. Answer. Correct answer. A. Explanation. Standing water inside ducts promotes corrosion and microbial growth, compromising air quality and system longevity. It also leads to odors and potential health risks. Water presence does not improve airflow efficiency. Rather, it increases resistance and may cause damage to duct insulation. Moisture generally deteriorates seals and joints, not improves them. Proper duct slope ensures drainage, preventing water accumulation and related issues as per building codes. Question 23. As illustrated by HVAC system schematics, Johnson notices the system uses a combination of welded and lock seam duct connections. which best describes when welding is preferred over lock-seam methods. A. When a permanent, airtight, and stronger joint is required. B. When faster installation is the priority. C. For easily removable duct sections for maintenance. D. To reduce labor costs on large projects. Answer. Correct answer. B. Explanation. Welding provides a permanent, airtight, and strong joint but is labor-intensive and time-consuming. Lock-seam connections are faster and allow some flexibility for adjustments and maintenance. Welding is chosen when joints must withstand high-pressure, corrosive environments or structural stress. Faster installation is often better achieved with lock seams or mechanical fasteners. Hence, welding is preferred for durability and not speed or removability. Question 24. Taking into account the fundamental principles of shop fabrication, Mr. Silver must select the correct sequence for cutting, bending, and assembling a complex duct component. Which order best minimizes fabrication errors? A. Assemble, cut, then bend. B. Bend, assemble, then cut. C. Cut, bend, then assemble. D. Cut, assemble, then bend. Answer. Correct answer. D. Explanation. The standard practice is to cut sheet metal to required sizes first, then bend to specified angles, and finally assemble components. Bending after assembly is inefficient and may damage joints or distort shapes. Cutting after assembly is impractical and risks misalignment. This sequence ensures accurate dimensions, maintains structural integrity, and aligns with fabrication best practices, minimizing errors and rework. Question 25. In the absence of adequate ventilation, Mr. Brooks is concerned about hazardous fumes while using adhesives in confined spaces. What is the best safety measure to mitigate this risk at use? A respirator approved for organic vapors. B. Work faster to reduce exposure time. C. Rely on natural airflow without mechanical ventilation. D. Use water-based adhesives only. Answer. Correct answer. A. Explanation. Using a respirator designed for organic vapors is essential in confined spaces with hazardous fumes, protecting the worker's respiratory system. Working faster does not ensure safety and may increase accident risk. Natural airflow is often insufficient in confined spaces. Water-based adhesives may reduce fumes but are not always suitable for all applications. Following OSHA guidelines on ventilation and PP, critical to safe adhesive use in HVACR environments. Question 26. When faced with the challenge of insulating ductwork exposed to extreme temperature variations, O'Neill considers the materials available. Which insulation property is most critical to ensure long-term system performance? A. High compressive strength to resist mechanical damage. B. Low thermal conductivity to reduce heat transfer. C. Bright color to reflect sunlight. D. Flexibility for easy installation. Answer. Correct answer. B. Explanation. Low thermal conductivity is crucial to minimize heat loss or gain through duct surfaces, maintaining HVAC system efficiency. Compressive strength is important but secondary since mechanical protection can be provided by jacketing. Color reflecting sunlight helps reduce surface temperature but doesn't affect insulation performance significantly. Flexibility eases installation but does not impact thermal properties. Insulation reduces energy costs and prevents condensation and related issues. Question 27. From the perspective of system components, Mr. Harris must install dampers to regulate airflow in different zones. Which damper type provides the most precise airflow control? A. Opposed blade damper. B. Single blade damper. C. Butterfly damper. D. Backdraft damper. Answer. Correct answer. A. Explanation. Opposed blade dampers allow for finer control because blades move in opposite directions, adjusting airflow smoothly and evenly. Single blade dampers offer simpler, less precise control. Butterfly dampers are often used for on-off or coarse adjustment, not precise modulation. Backdraft dampers prevent reverse airflow and do not regulate airflow quantity. Selection should consider airflow control, accuracy for system balancing, and comfort. Question 20. In terms of troubleshooting duct leakage, Parker uses a smoke pencil to detect leaks around duct joints. Which of the following conditions would most accurately confirm the presence of a leak? A. Smoke flow directed into the duct from the surrounding air. B. Smoke swirling or escaping outwards from a joint or seam. C. Smoke dissipating quickly with no directional flow. D. Smoke remaining still near duct surfaces. Answer. Correct answer. B. Explanation. Smoke escaping outwards from a joint indicates air leaking out of the duct system, confirming leakage. Smoke flowing inward suggests negative pressure drawing smoke in, not leakage. Quick dissipation or still smoke shows no airflow or leak. Using smoke pencils helps pinpoint leaks visually, improving sealing and energy efficiency per HVACR best practices. Question 29. Given the circumstances of a rooftop ductwork installation, HRConquer must ensure proper support spacing to prevent sagging and vibration. What is the recommended maximum spacing for supports on rectangular ducts? A. 6 feet. B. 8 feet. C. 10 feet. D. 12 feet. Answer. Correct answer. B. Explanation. Support spacing typically depends on duct size and material, but 8 feet is a common maximum for rectangular sheet metal ducts to prevent sagging and vibration per SMT standards. Too wide spacing risks deformation and noise issues. Closer spacing increases labor and materials costs unnecessarily. Choosing appropriate spacing balances structural integrity, performance, and cost effectiveness. Question 30. The underlying principle of duct leakage control is being tested in a commercial project where Alvarez is tasked with ensuring the installed rectangular ductwork meets SMT Class 3 leakage requirements. Midway through testing, results show airflow losses exceeding the allowable percentage. What is the most effective corrective action she should prioritize? A. Increase fan speed to compensate for losses. B. Reseal all transverse joints and longitudinal seams. C. Replace all duct sections with heavier gauge metal. D. Install additional balancing dampers. Answer. Correct answer. B. Explanation. The most effective correction is resealing transverse joints and seams, as leakage primarily occurs at these points. Increasing fan speed masks the symptom and increases energy use. Heavier gauge metal doesn't directly reduce leaks unless the issue is structural failure, which is rare. Additional dampers improve balance, not leakage. SMT standards emphasize sealing integrity over airflow compensation, making duct sealing essential for compliance and efficiency.